Hello and welcome to today's video lesson. Today we're going to dive deeper into C++ and we're going to explore how we can use classes to represent real-world objects. So by now, you should be familiar with the basics of C++, like variables and functions and certain control structures. So today we're going to focus on a key concept in object-oriented programming called class design. And this is fundamental for creating reusable modular code. So our goal today is to understand how to design a class in C++, and we're going to use an example. We're going to use a sphere class. This class is going to help us encapsulate properties and behaviors related to a sphere, such as its radius, its surface area, I think volume. It's going to be located on the, there's a PDF in week 2 that has a prompt, a lab that you can follow along with here. So the definition of a class is like a blueprint for creating objects. It defines properties, which are attributes, and methods, which are functions, that the objects created from the class is going to have. So you can think of a class as a template or a prototype. And when you define a class, you're setting up a model. You can then create objects based on that model. So I want you to think, if you were making, let's say, a ball, you were creating a ball in C++, and you created variables that store its size, you created variables that just stored its surface area and other things. And then you wanted to create another ball. And then you'd have to do the process all over again. And you would have to, okay, well, I'm going to set this to this. I have to create this variable here. And then you would continuously do that to make different spheres. Well, instead, we use classes because it allows us to reuse that code that we made. We have a blueprint for creating an object, and we simply apply the blueprint each time we want to make a sphere in our example. So classes allow us to bundle data and functions that operate on that data together. This is encapsulation, and it makes our code a lot more organized and more modular. So for example, if you had a graphics program, you might have a circle class, a square class, a triangle class, a polygon class, and so on. So each class would handle everything related to its own shape. And we're going to create the basic structure of a class. So the first thing we want to do is create a header file. So I'm going to create a new file, and we're going to call this sphere.h. And it wants me to save it somewhere. I guess I'll just create the file here. It's fine. And then this should be nice and big, so you should be able to see the text here. Yeah, that's fine. I might make that smaller, I'm not sure yet. So basically what we're going to do is we're going to use the class keyword, and we're going to put the class name. So this is going to be called sphere, and you capitalize the first letter of the class, and then we're going to have public variables, and we're going to have private variables. And then we're going to put a semicolon at the end of these curly braces. So this is our class name. So whatever we name our class, we're going to put it here. And then we have public and private specifiers that control where the class members can be specified. So there's reasons why we would want to make something public and reasons why we'd want to make something private. So you'd want something to be private if you don't want that to be edited, you don't want it to be accessed, and then you would make things public if you don't mind that it's accessible from anywhere else in the code. And so this is going to be decision specific to whatever it is you're doing. So here we're going to also we're going to type in hashtag ifdef, and we're going to put an underscore, and then in all caps, the name of the class, and then we're going to hashtag define underscore sphere. And and we're going to end if as well. So in the bottom we put end if. Can you see that? There we go. Now you can see it. So this is the basic structure of a class, and we're going to create some member variables and we're going to create some methods. So we're going to first start with a default constructor and we're going to make that public. So the constructor constructs the object. So we are going to say sphere, we put the name of the class, we put parentheses, and then we put a semicolon after. And then we can also create something called an overloaded constructor. Double, and then we want to say radius parameter. So now we have a default constructor. So no matter what, when we get a sphere, it's going to be created from this. It's going to have a default constructor. So if we don't specify what the parameters are, it's still going to create the object. And then in here, we're going to call this an overloaded constructor. And the overloaded constructor is going to, it's going to allow us to put a variable, or we're going to set a variable into the sphere object. So let's see, what else do we have here? We're going to create a setter. So we want to set some things. Let's go ahead and, so we're going to say void set radius. This is going to be a method specific to the class. So it's like a function that's going to be specific to this class, and it's going to take a variable radius parameter. And so this is our mutator. And then we're going to create a method that gets the radius. Oops. And then this is going to get nothing. And this is our accessor. Okay, I'm just trying to keep up with what's visible on the screen because I do have it a bit close up. Let me see if I can change this so that it's not as close up. So I'm going to go to settings. I'm going to go to settings here, and I'm going to change the font to 24, and then I'm going to go back, and then I'm going to minus. Okay, I think that's a little bit better. Hopefully you can still see that though. So here's what we have so far. So we have a getter, so that's something that's going to get the value, and we have a setter, something that's going to set the value for us. We have, like I mentioned before, we have our constructors, which initialize our objects, and we have two. We have a default one, and we have an overloaded one that takes a parameter. And we're going to have private members. The radius is going to be private, which means that it can only be accessed or modified through a public method. So this is a good practice for encapsulation. So let's go ahead and make radius right now. So in the program, we're protecting radius. It's private so that it can't be changed easily. We don't want it to be just accessed anywhere in the code. Again, good practice for encapsulation. To talk a little bit more about our constructors, the constructors are a special function that are called automatically when an object is created. They help set up an object in a valid state. In our sphere class, the default constructor initializes the radius to 0, while the overloaded constructor is going to allow us to initialize radius with a specific value. So we're going to get to that when we create the implementation file. So again, this is the header file. It's where we have all of our definitions. And our implementation file is where we're going to implement those definitions. We're going to define them there. Encapsulation is a principle in object-oriented programming that bundles the data, the attributes, and the methods that operate on the data into a single class or like a single unit. It restricts direct access to some of the object's components, which can prevent accidental misuse of those variables. So in the sphere class, the radius attribute is going to be private, and the only way to modify it or access it is going to be through the setter, set radius. So that's this right here, or get radius. Let's call this our getter. Let's call this our setter. So we have our getter and we have our setter. And this is a classic example of encapsulation. So that's going to be our header file. Next, we're going to create our implementation file. So I'm going to come up here. I'm going to create a new file, and I'm going to call it sphere, capital sphere, or how about lowercase sphere? Because I want to be consistent. Again, like you want to be consistent with your naming. So in this case, I didn't capitalize sphere.h, so I'm not going to capitalize it here. Consistency is going to be it's going to be just as important as using industry standards. So if you're going to do something different than an industry standard, at least make it consistent. So I just wanted to say that there. And it's going to be called sphere.cpp. This is going to be the implementation file. So again, we're using the class name. In this example, we've lowercased the s in sphere, and we're calling it sphere.cpp. So this is, again, another convention. So we have a sphere.h, which is our header file, and a sphere.cpp, which is going to be our implementation file. And the title of each of these files is the class name. And that's another way we're going to stay organized through this encapsulation. And I'm going to just save it to my downloads. I don't care. You will care. I think you're going to want to have a project folder for this class. So let's go ahead and do some things. I will explain them on the way. So we're going to include sphere.h. So we want to be able to, include all of those definitions from the sphere.h file. So we have to include it up here. Let me make sure I spelled it right. The sphere is kind of like a weird word. And we're going to include IOStream. We're going to include CMath. Oh, there we go. I'm getting all jumbled up. I had classes this week. I'm also a student in a master's program, and it is jumbling up my brain. There's so much work in that program. So I apologize ahead of time if I skip over some things. I'm sorry about that. I'm not trying to make excuses, but I just want you to understand what's going on. So we're going to go here, and we're going to look at what we have. We're going to create functions that define. So these are kind of like our function prototypes. They are our definitions, and we're going to define them here. So to do so, we want to first we want to write in what type it is, and our constructor is going to be special. It's going to be sphere. Scope resolution operator, that's the two colons are called scope resolution operator. And we're going to say sphere, parentheses. And we're going to do something when we construct a sphere. So the first thing that we want to do when we construct a sphere is we want to set its radius, because this is going to be for our default constructor. So somebody made a sphere and they didn't set what the radius is going to be. So what are we going to do? We're going to establish the radius at 0. And what type of variable is radius? It's a double. So we're going to make sure that we're consistent there. So when we create our constructor definition, we want to start with the class name, scope resolution operator, and then the name of your constructor. In this case, the name of the constructor is just the name of the class, and then whatever you want to do when you construct. Hold on. I'm looking at this and it's kind of getting mad at me here. Expected a semicolon. Okay. Oh. I've been coding in Python too long. I almost forgot. I was like, is this a struct or something? What's going on? So I almost forgot to put in my semicolon because I mostly code in Python, where you don't have to put things like, you don't have to put magical things like semicolons at the end of statements, but in C++ we do. Sorry about that. That was quite funny to me. We're going to create the definition for the default or for the overloaded constructor. And remember, this takes a variable, radius par. And we're going to, this time, I'm not going to forget to put a semicolon at the end of each statement. So I'm sorry, I don't think it's that amusing, but it is so amusing to me. Just these little moments of laughter because there's just so much pressure in this master's program right now. So sphere. So we're gonna say if, and then radius par, and then our oops. And then we're going to say if radius par is greater than 0. So remember, we want to do some sort of valid input checking here because it's a good idea to do so. We're going to make sure that the user put in a valid number for their radius variable. We're going to say radius is, we're going to set radius to radius parameter. So radius equals whatever the user put. So in that case, we're going to set it to that value. And then if not, we don't want like negative radius, for example. We don't want those types of things. So in that case, if they put anything else, if the user puts anything else, we're simply going to make this 0 so that the user can't break our code. We have cases that handle that. And you want to check that you have a code that will account for that. So both of our constructors are going to ensure that radius starts in a valid state, is what I'm saying. So either we set it to 0 or a positive value by the user. So now we're going to create our setter. And now, so I'm going to go back here. So now we have void set radius. This is our setter. I'm going to copy this here. And if at any point, if for any reason something's wrong with the audio of the video or something's wrong with the visuals of the video, just send me a message and tell me so that I can fix it. A couple students mentioned that the previous videos, their text was a little bit too small. And so in this video, I fixed it. So it always helps whenever you guys your feedback is really important to me is what I'm trying to say. So I'm going to put the set radius here and I'm going to define it by putting curly braces afterward. And there's something else I need to do before I can define my, set radius. I need to specify the sphere class and then the scope resolution operator, and then the name of the function that I'm going to define, or the method. When it's part of a class, it's called a method. And let's see, I'm double checking and I'm making sure that I'm doing everything correct because I want this to run the first time. I know it's mythical when it runs properly the first time, and I'm always chasing that mythical feeling. So void sphere, scope resolution operator, set radius, double radius part. And I'm actually going to copy this code. And I'm going to put it here. So in this example, the setter isn't really super useful because we already have something performing that. But because you're just learning about classes, we're going to specify a setter. We're going to specify this again. So The reason why we're doing the same thing that we did before is simply because I want you to understand kind of how a setter works. And even though we already we already did some sort of an error handling in our overloaded constructor, we are going to also, we're also going to do that for our set radius. And again, this is still good practice for you so that you get used to these principles. I'm going to drink some water. My mouth gets dry when I lecture. Okay, so that's our setter. Once again, I'm just double checking. And now we want a getter. We want to define our getter. So we're going to go, I'm going to scroll down a little bit so you can see. And I'm going to go back here. And okay, that's of type double. I'm going to copy. I'm going to come back to sphere.cpp. I'm going to paste. And then I'm going to remember, I need to specify getRadius is part of the sphere class from that sphere.h file. So I'm going to say sphere scope resolution operator getRadius. And it's going to return a double. So I have my double in front. So all this is going to do is it's going to return the radius. So I'm going to say return radius. That's it. That's all it does. And then we're going to have more interesting functions. So we're going to have, we can have calculate surface area. We can have calculate volume. We'll go ahead and we'll do some of those. So I'm going to make those, let me put some space there. I'm just checking and making sure you can see what I'm doing. I'm actually going to put this back together. And so now we have our setter, now we have our getter. I want to create a function that calculates surface area. Double calc surface area. And it's going to take a double radius part. And we're going to have another function that calculates the volume. And it's going to use double radius part. Okay, don't forget your semicolon. I definitely will not be forgetting it anytime in the future now that I've made that one mistake. And so I'm going to copy both of these. And I'm going to go to my implementation file and I'm going to paste them down here. Let's go ahead and make this go here, make this go here. And then we're just setting these up so that we can use them. So once again, once you copied and pasted the name of your method over, don't forget, you need to put the name of the class and the scope resolution operator, which are these two semicolons. These are, no, colons right here. And then the name of your function. And then whatever your function is going to do is going to be in here. Whatever arguments you're going to use is going to go here, whatever parameters. And then it's a lot of housekeeping. It's a lot of, did I put the thing in the thing? It's a lot of that. So classes can seem tedious in their setup, but once again, if you're going to be using like spheres in this example, if you're going to be making a whole bunch of different types of spheres like basketballs and golf balls, or whatever else might be a sphere, the world might be a sphere. So we're going to want to do the work from a blueprint. We don't want to have to code that all over again. So calculating surface area, I actually have the formula right here. So I'm going to, otherwise you can Google it right now. You can, okay, how do I calculate the surface area of a sphere? But I already Googled it. So it's going to be 4.0 times pi. I should have created a constant, right? I could have done that. 1596. And I'm going to times square radius par 2.0. So I could always do radius par times radius par to do the square, but we included CMath up here because we wanted to make it a little bit easier on ourselves, and this is easier for us to read, and we wanted to review this function. Now, we're going to calculate the volume. And once again, you can Google this. I already Googled this, so you can just copy it down. Return 4 points. That would have been weird. 4.0 backslash 3.0. So do this first. We're doing order of operations. Remember, that matters in C++. Radius par 3.0 times pi, 3.141596. So I think this looks good. I'm just double checking to make sure I got the formulas correct so that you don't get an error when you run this. Okay, that looks good. That looks good. So once again, I just want to draw attention here and here. So I have two methods of input validation. So notice how we validate inputs in both the set radius and the constructor method. This is crucial because we want to prevent erroneous inputs. We want to avoid unexpected behavior. And in this example, again, we're using pi as a number, a literal. However, in real applications, you'd want to use, you could use m_pi from CMath for more precision, or you can create a constant. And then we use the pow function from CMath to compute powers for the area and volume calculations, as mentioned before. So now we've set everything up. Now we want to use it. So I'm going to create a new file, and we're going to call it main.cpp, and I'm going to just put it in my downloads. Okay, and we need to include IOStream. So this is going to be where we're going to use the sphere class. We're going to use it here. We made our header file, we made our implementation file, and now we're ready to use it. So hashtag include string. And we're going to include sphere.h. We want to use stuff from the sphere class that we created. So we made this ourselves. So we're including the header, and then from there we're going to be able to use all of our methods, and we're going to be able to set our member variables and other things. So using namespace std, and then our boilerplate. Return 0. You can put system pause here if you want to. I think it should work okay with my operating system. I'm using Linux, and I know that it works with Windows. I'm not sure if it works with Mac or iOS, which shows you how much I know about iOS. Double radius temp. Okay, so we made a variable that's going to store whatever the user puts in for the radius, and we're going to make a sphere. We're going to start by making a sphere without an initial radius. And let's say we wanted to, let's say, so in this example, we made a basketball, and we didn't instantiate an initial radius, but we can do something. We can actually instantiate a radius like this. So I just inputted double radius par. I inputted this value 2.0 because we specified that we're going to have a sphere, an overloaded constructor for a sphere that takes a variable, that takes a parameter. Sorry about that. Let's go back to main. Okay, so that's how that goes. And then we're going to get the user input. We're going to do a calculation. We're going to output. And then here these are our declarations. So this is typically the kind of thing that we do in this class. And you did it in your last class, and you're going to be doing it again for this class. It's nice to have some familiarity when there's new situations. And this is all new to you, I think. Maybe a couple of you know what this is already, but you're still taking this class. What is the radius for the basketball? Okay, and then we're going to see in radius temp. Okay, and then once the user inputs what that radius temp is going to be, we want to set the radius. So something that we do is we type in the name of the object. So this is the class sphere, and this is our object, and we named our object basketball. And so I'm going to say basketball. And now I'm going to press the dot operator, and you see that we have different functions associated with a basketball object. And that's pretty cool, right? Because you don't have to write any of these explicitly. You've already done so. So now you can call on one of these methods. And in this case, we're going to set radius. So we want to set radius to whatever the user put, radius temp. Okay, I hope you're still following along, and I hope you're enjoying the lesson so far. We're already almost done. So radius temp is basketball dot get radius, and there we go. So this is how we're able to get the radius of the basketball object, and that's one way to access it. What else? Now we're just going to see out basketball. I want to put a colon here. Okay, we're creating our output, and we're going to output the surface area, and we're going to output the volume. So this is rather simple, right? So see out surface area, and then we want basketball dot calc surface area, and we put radius temp, right? And we see out get user input, calculation, and output. We could get rid of this actually. Okay, surface area, and then we're going to get the volume. Basketball dot calc volume, and then this is going to take radius temp. Okay. So this is some output that you can do. I also have some more. You can do this a little different. So I have it so far that you can do the calculation and output this way, but I want you to see that there is another way. Another way is 2 words. To calculate. So another way we can calculate is we could see out, let's just say basketball again. It's going to look the same. I could have copied that, I didn't. See out surface area. And then basketball dot calc surface area. And then instead of saying radius temp, we can actually say basketball dot get radius. What do you think? What do you think? That's pretty cool, right? So in this example, we are accessing the radius. We're using the getter to access the radius, and we're using that value to calculate. And then see out volume. Basketball dots calc volume. And then we're going to do basketball dot get radius. Okay. And that's that. So I wanted to show you another way that you can calculate this. So don't get confused. This get radius, again, this is simply just the method. So when we inputted radius temp, when the user inputted the radius temp, we had this definition take place, so set radius. And then when we get the radius, where you get radius, we return the radius. We simply do so that way. So we created an object called basketball, and we used the default constructor at first, but this is how to use the overloaded constructor, this example. So remember, when we use the default constructor, we didn't put this here, right? So those are just a couple things you can do. We prompted the user to enter a radius for the basketball, and we set it using the set radius method. We calculated and displayed the surface area and volume for the basketball using the member functions or the methods, and we did it in 2 different ways. Let's go ahead and run the code. Sometimes it doesn't work on my machine, but I'm going to try to run it, and then if it doesn't run, I'll see what's wrong with it and I'll update it. But let's see. So run without debugging, and then I think I use this one. Oops. Okay, so it looks like it didn't want to run. I'm going to go ahead and I'm going to fix this. So I'm going to stop recording here, and then I'm going to fix the error, and then I'll disclose to you what the error was. Hello, so it turns out that I had capitalized sphere up here, the essence sphere for sphere.h, and it is lowercase, and you see that here, that I also have it. I had the error here in the implementation and the main file, so if you had that error as well, go ahead and change it. When we created sphere.h, we lowercase this file, so the essence sphere was lowercase. So when we call that header file, we need to make sure that it's spelled the exact same way. And I have Linux, so I run things in the terminal, and so I can show you what my program looks like now. So I'm going to, so when you compile the code, you simply do this, and to run the code, I'm going to do this. So it says, what is the radius for the basketball? And we're going to say 2.0. So basketball surface area is 50.2655, volume 33.51. And then the same thing using the other method with the getter. And that's it. So like I said, go ahead and go back and fix that error. I had accidentally capitalized the S in sphere when it shouldn't have been. And that should fix your program. I also put using namespace std here in the implementation file because sometimes you get an error where you need to do std and then use pow. So if you're still getting an error, go ahead and try to fix that by using namespace std up here in the implementation file. So that's going to conclude this lesson in classes.